All right, let's look at the homework 15.3, problem number 10. All right, so let's evaluate this integral. All right, so let's say D is just a rectangular region, so it's easy enough. So let's separate this into three double integrals. All right, so this is going to be, all right, so you have a double integral here, and I'll do the 4ax to the 7th power, right? And then, all right, so I'm going to do with respect x first, then so dx dy, right? So since we're doing a dx first, so it's a negative a to positive a, negative b to positive b, right? For the second term, so I'm going to do this one with respect to y. So you have a 7b y to the 7th power. We do dy dx. So I'm doing dy first, so a negative b to b goes first, and a negative a to a, right? So the last one, so you have a double integral here, right? It's a square root of a squared minus x squared. I'm going to do this with respect to x first, since it's written in x. So it's going to go from negative a to positive a, negative b to positive b, right? So let's look at the first integral, right? And if you look at this integrand here, right, so 4a is just going to be a constant, and x to the 7th power, so we know that this is an odd function, right? Remember that if you integrate the odd function from negative a to positive a, the integral is going to be equal to 0, because the graph is symmetric about the origin. So left hand side and right hand side has the same magnitude with the different signs, so they cancel out. It's equal to 0. So integral 0 is going to be 0. So the whole thing actually becomes 0. Right? How about the second integral? Right? So you can actually do exactly the same thing. So this is actually again an odd function. So if you integrate from negative b to positive b, so this integral inside is going to be equal to 0. So the whole double integral is going to be equal to 0. Right? Then last one, we're going to use geometry here. Right? So we know that the square root of a squared minus x squared is going to be a semicircle, top semicircle. So it's going to look like this. Right, so you have a semicircle with radius a, so it's going to go from negative a to positive a, and it's a semicircle, so it would look something like this, right? And of course this is a there, right? So we're integrating this function from negative a to positive a, so we are looking at this region. So the integral inside represents the area of this shaded semicircular region, right? And we know how to find the area there. So that area is so it's a pi r, in this case a squared. He'll give you the whole circle, so you have to divide by 2. Right? So we get that. So this inside integral is going to have a value of pi over 2 a squared. Right? Then if you integrate that, right? So if you want to integrate from negative b to positive b, then you have pi over 2 a squared with respect to y, right? Since this is going to be an even function, I'll do one more step. So this is going to be an even function because it's a constant function. This is even. So this is going to be equivalent to, right, instead of going from negative b to positive b, it's an even function is symmetric about the y-axis. I'm going to actually go from 0 to b, which is a half of it. Then you just have to multiply by 2. right? So you have a pi over 2a squared dy, right? Then we can cancel 2 on top and 2 on the bottom, and the pi a squared is just going to be a number, so I'm going to just pull those out. Then you have, so it's got 1, antiderivative of 1 is y, and y is going from 0 to b, right? So this is going to give us pi a squared, plug in b minus 0, so it's just going to be b. So pi a squared b is the answer. All right, so let's type it in. All right, so we got the pi a squared times b, right? Let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.